Hello everyone, in today's video I am going to talk about input and output impedances. So I will teach you the systematic approach. We will not draw AC analysis, AC equivalent circuit all the time and find our input and our output simply by KCL and KVL equations. I will teach you the systematic approach and you will do this analysis all the time in problem solving. First of all, if you have a BGT in AC case like this, and if you look from here, what you see is RP, and RP equals beta force over GM. Okay, if you see in AC case, if you look at the circuit and look for output resistance from here, what you see is RCA. Okay, what is RCA? RC is V early voltage divided by IC. In our analysis thus far, I always neglected RC component because it is too much. If you think IC 1 milliampere and VI is like 150 and it makes 50k or 100k, it is large compared to other elements of the circuit, so we always neglected it, but from now on we will take account it. And if you have a AC equivalent of this in AC analysis and you look from here, what you see is RCE. Okay, let's now move on. Okay, in VA early voltage, when early voltage is infinite and you look from emitter side, what you see is 1 over GM. Okay, also when VA is infinite, when we don't take account the RC component and look from here, what you see is RP plus beta plus 1 times RE, and sometimes we call it RBE. Okay, the last one is about BGT. What you see from here is RCE plus RE plus GM RCE times RE. Okay, this was BGT equivalent input and output resistances. Sorry, one is remained, and it is this AC. When VA is taken infinite and you again look from emitter side, but here be careful, there is RB resistance here at the base side. So what you see, it becomes 1 over GM plus RB divided by beta plus 1. So this was our BGT case. Now let's move on to MOSFET. In MOSFET, this time there is RDS components, are the drain source resistance due to channel length modulation lambda. So let's look at first one. What we see from gate is infinite. Why? Because gate current was 0 Okay, this was the first one. If gate is grounded, source is grounded, and if we look from the drain side, what we see is RDS resistance. Okay, let's draw the third one. If you look from the when lambda equals 0, and if you look from the source side, what you see is 1 over Gm. It is similar to actually it is similar to BJT case. And you can make the analogy. For example, if this was BJT, what you see from above was RCE. Or if this was BJT, what you see above the emitter 1 over Gm, it's equivalent actually. But remember, what is the difference between MOSFET and BJT? In MOSFET, what you see from the gate is infinite. Okay, let's move on. So the final one is what you see from here. This time, what you see is RS plus RO plus GM RS RDS. Okay, I made a mistake. Where I made a mistake here, it is not. Here what we see is RE parallel RP. Remember, RP was beta force over GM plus RCE plus GM RCE RE parallel RP. Okay, so in MOSFET equivalent, what we see is RS plus RDS plus GM-RS RDS, what we see from output of the MOSFET. So that's it, guys. These input and output resistances, we will use it a lot. And let's now collect all the information what we see, what we know about BJT and MOSFET, its gain and input and output resistances. In a BJT, we have calculated all the formulas actually about the gain. What is Vc over V base? It is common emitter gain, and we have calculated it. It is minus Gm Rc over 1 plus Gm Re. In its MOSFET equivalent, we have calculated V drain over V gate gain, and it was equals to minus Gm R drain over 1 plus Gm Rs. You can, if you hesitate here, you can go to my previous videos and take a look at the common emitter video, or common gate or common base videos, and you will see that we have calculated these gains. So you can make the analogy between MOSFET and BJT case. Here in BJT, gain is minus Gm times what is seen at the collector divided by 1 plus Gm times what is outside of the emitter resistance. In MOSFET equivalent, collector becomes drain and emitter becomes source, and Gm formulas, remember, in BJT, Gm equals IC over Vt. In MOSFET, Gm equals square root of 2 times ID times Kn. So what is V collector over V emitter? Also we have calculated this. It is Gm Rc over 1 plus Gm Rb over beta force. In MOSFET equivalent, you can think beta force is infinite in MOSFET. So this equation becomes GMRD in MOSFET. V drain over V gate, V drain over V source equals directly GMRD in MOSFETs. Okay. Why we think beta force is infinite? Because our input is, our gate is infinite in MOSFET case, and we can think beta force infinite in MOSFET, thus we make our gate equals infinite. Okay, so what is V emitter over V base? We also calculated this. It is GM array over 1 plus GM array, and its MOSFET equivalent is V source over V gate, and it is GMR source over 1 plus GMR source. So what I have done is giving you all the formulas, all my derivations, input and output resistance, and all the gain equations that you should know by heart. We all did AC and DC analysis of this, and we have derived these formulas. So in problem solving, I will use these formulas a lot by heart, and I will always remind you these formulas, but you should know this by heart, guys. If you want to move on electronics, if you want to do analog electronics, digital electronics, or analog integrated circuits, you should know all these formulas. Okay, so actually that's it, guys, for today. I will start problem solving on next video. Take care of yourself. Have a nice day.